Hello students, in today's video I am going to discuss that what do we mean by homogeneous function. Students, suppose fxy is a function based upon two independent variables and degree of this is equal to n. Students, in order to verify that the given function is a homogeneous function or not, there are a few steps. Different ways are actually here. If first way is here, if I am writing f of lambda x comma lambda y is equal to lambda to the power n into fxy, then I will say that this function fxy is a homogeneous function. It is a homogeneous function of degree n. Second way is like, if this function fxy I can write like x to the power n into function of another function of y upon x, then also I can say fxy is a homogeneous function of degree n. Third way is also there. If this function fxy I can write y to the power n into function of actually x upon y, y to the power n into function of x upon y, then also I will say that fxy is a homogeneous function of degree n. So students, how we can understand all these three ways? If any one of this is applicable, then we can say the given function is homogeneous with the given degree. Students, I will verify all the methods here. Suppose a function I am taking here, f equal to x cube plus y cube upon x plus y. Actually, I will write here f of xy. It is f of x comma y. I am applying here first method. So in order to apply first method, what I will do, I will evaluate f lambda x lambda y. So x is replaced by lambda x, y is replaced by lambda y throughout the given terms. So it is lambda x whole cube plus lambda y whole cube upon lambda x plus lambda y. Ultimately I can take lambda cube outside, so and in denominator lambda as a common term, that is x cube plus y cube upon x plus y, or it is lambda square into x cube plus y cube upon x plus y. Students, we can write it lambda square into function of xy. So that was actually equal to f of lambda x comma lambda y. If you will observe here, this function is a homogeneous function of degree 2, because f of lambda x comma lambda y is equal to lambda to the power n, and here n is equal to 2 into the original function. So yes, it is a homogeneous function. It is a homogeneous function of degree 2. Now students, we will verify the same function by this second method. So here fxy is given to us like x cube plus y cube upon x plus y. Here I have to take x to the power something common. So from numerator and denominator I will take x common, maximum possible value of x common. So here I will be taking x cube common, so that is 1 upon y by x whole cube, and here I am taking x common, that is 1 plus y by x only. So ultimately students, it is x square into, and if you will see this function, it is 1 plus y by x whole cube and upon 1 plus y by x. This is actually the function of y upon x. So it is actually x square into function of y by x, and it was actually equal to f of x comma y. So yes, in such a way as well, the original function is written like x to the power n, and here n is 2 into function of y by x. So I will say yes, this is also homogeneous function of degree 2 by second method. Students, in the similar way, if I am going to apply the third method and the function is same, fxy is x cube plus y cube upon x plus y. So what I can do here, I can take the maximum possible value of y common from numerator and denominator. So y cube is common, that is 1 plus x upon y whole cube, and here y is common, that is 1 plus x upon y. Or students, it may be written y square, and it is just like 1 plus x upon y whole cube upon 1 plus x upon y. So student, if you will observe it, it is just function of x upon y, that is y square into function of x upon y, and it is equal to fxy. So in this way as well, the given function is homogeneous function with degree 2. Now students, I have discussed the homogeneous function in two variables. What if the function is depending upon three variables? Then how to discuss it? So our next topic is like homogeneous function in three variables. Homogeneous function in three variables. So students, in this way, I am taking a function f of x, y and z. So there are few more ways to understand this concept. First way is like if I am writing f of lambda x, lambda y, lambda z is equal to lambda to the power n into the original function, then we will say that f is homogeneous function. F is homogeneous function of degree n. Now students, thereafter, what is the second way? If this original function fx, y, z can be written like x to the power n into function of y upon x comma z upon x, then also the given function is homogeneous. Third way is like if I can write fx, y, z is y to the power n into function of x upon y and z upon y, then also students, it will be a homogeneous function. And the last way is here, if I can write fx, y, z equals to z to the power n into function of x upon z and y upon z, then also we will say that it is a homogeneous function of degree n. Now students, I will be taking one example in each and every aspect here, and our example is like here, fx, y, z is equal to suppose x square plus y square plus z square upon x plus y plus z. So students, if I will say here, I want to apply here first method. If any one of these method is applicable, then function will be homogeneous. So I will be evaluating here f of lambda x, lambda y, lambda z. So it will be lambda x whole square plus lambda y whole square plus lambda z whole square upon lambda x plus lambda y plus lambda z. So here lambda square is common from numerator and lambda is common from denominator. So it is x square plus y square plus z square, and it is x plus y plus z. Ultimately it is lambda into x square plus y square plus z square upon x plus y plus z, or students, it is lambda into function of x, y, z, and which was equated to lambda x, function of lambda x, lambda y and lambda z. If you will see, if you will observe, this particular is function of lambda x, lambda y, lambda z is equal to lambda to the power 1, where degree is 1 into the original function which is fulfilling this criteria. So I will say yes, the given function is homogeneous function with degree equal to 1. Now students, if you will try to verify the given function for homogeneous property via this second aspect, then what we can do here. So here fx y z, as it is given like x square plus y square plus z square upon x plus y plus z. So students, I will be taking maximum possible power of x common. So that is x square from numerator. So that will be 1 plus y upon x whole square plus z upon x whole square, and upon x here common, that will be 1 plus y upon x plus z upon x. Students, y it is actually z upon x. Yes. So now students, actually let me write it again. It is just like y upon x plus z upon x. That's it. Students, if you will see this function, this whole function, how it can be written. Okay. One more thing here, x square upon x is x to the power 1, and this whole function is function which is depending upon y upon x and z upon x. Y upon x and z upon x. So students, original function is written like x to the power something into function of y upon x and z upon x, and that something is equal to 1 here. So as per this property, again I will say that this function is homogeneous function with degree equal to 1. Students, now the same function I am going to tackle via property 3. That is here fx y z is x square plus y square plus z square upon x plus y plus z. Here I will try to take maximum possible power of y common from numerator and denominator. So from numerator it will create 1 plus x upon y whole square plus z upon y whole square, and from denominator it will create 1 plus x upon y plus z upon y. If you will observe here, this whole function is function of x upon y and z upon y. So it is y square upon y, that is y to the power 1 into function of x upon y and z upon y. So again, via the property, this property I am talking about, the given function is homogeneous function with degree equal to 1. And the last property is here, this where we have to take z to the power maximum possible power of z common. So it is function of x y z. The same example is there, x square plus y square plus z square upon x plus y plus z. So students, I will be taking maximum possible power of z common from numerator and from denominator. So it is 1 plus x upon z whole square plus y upon z whole square, and here it is like 1 plus x upon z plus y upon z. If I will say students, this is a function of x upon z and y upon z. So that is z square upon z, that is z into function of x upon z and y upon z, and it is actually z to the power 1. If you will observe here, it is again a homogeneous function with degree 1 via this property 3. So it is a homogeneous function with degree 1. So students, in this particular video, I have discussed that how to identify the homogeneous function in 2 variables with degree n, as well as I have discussed that how to identify the homogeneous function in 3 variables with degree n. Students, I hope that this video will be helpful for you in order to identify the homogeneous function. Thank you so much for watching this video.